Chapter 4 Installation. Here we go. So, three parts: installation methods, installing step by step, and after the first boot. Installation methods contains installing from a CD-ROM, DVD-ROM, booting from a USB key, installing through network booting, and other installation methods. Installing step by step includes booting and starting the installer, selecting the language, selecting the country, selecting the keyboard layout, detecting hardware, loading components, detecting network hardware, configuring the network, administrator password, creating the first user, configuring the clock, detecting disk and other devices, starting the partitioning tool, installing the base system, configuring the package manager, apps, Debian package popularity contest, selecting packages for installation, installing the grub bootloader, finishing the installation and rebooting. And the third section after the first boot includes installing additional software and upgrading the system. This is a long chapter, but now we finally start with using Debian. To use Debian, you need to install it on a computer. This task is taken care of by the Debian installer program. A proper installation involves many operations. This chapter reviews them into their chronological order. Back to basics, a catch-up course in the appendices. Installing a computer is always way simpler when you're familiar with the way it looks. If you're not, make a quick detour to Appendix B, a short remedial course before reading this chapter. Let's do that. Shell basic commands, browsing the directory tree, displaying and modifying text, system information, memory, disk space, identity. Short, let's read it. Appendix B, a short remedial course. Even though this book primarily targets administrators and power users, we wouldn't like to exclude motivated beginners. This appendix will therefore be a crash course describing the fundamental concepts involved in handling a Unix computer. B1. Shell and basic commands. In the Unix world, every administrator has to use the command line sooner or later, for example when the system fails to start properly and only provides a command line rescue mode. Being able to handle such an interface, therefore, is a basic survival skill for these circumstances. Quickly, starting the command interpreter. A command line environment can be run from the graphical desktop by an application known as Terminal. In GNOME, you can start it from the Activities overview that you get when you move the mouse in the top left corner of the screen by typing the first letters of the application name. In Plasma and many other desktop variants, you will find it in the Application menu, Applications System menu. This section only gives a quick peek at the commands. They all have many options not described here, so please refer to the abundant documentation in the respective manual pages. B11. Browsing the directory tree and managing files. Once session is open, the pwd command, which stands for print working directory, displays the current location in the file system. The current directory is changed with the cd command, directory command, cd directory command. Cd and then directory for the directory you want to use. It's an argument. cd is for change directory. The parent directory is always called ... two dots, where the current directory is also known as one dot. The ls command always allows listing the contents of a directory. If no parameters are given, it operates on the current directory. Here's an example. Here goes pwd and home or Herzog, cd desktop. He changes, he does pwd again, and it's in desktop, cd dot, and he's still in desktop, cd dot dot. He moves one up in the file system, and then he goes ls, and you can see the folders in his home directory. Desktop, downloads, pictures, templates, music, blah blah blah. A new directory can be created with the mkdir directory. Mkdir and an existing empty directory can be removed by our mdir directory. The and the command allows moving and or renaming files with and directories, and moving a file is achieved with rm file. Removing a file is removed with rm file. This is an example. He lists with ls, then he moves test to new. So now there's no test. It's called new instead, and then he removes new, and it does ls again. It's gone. B1.2 displaying and modifying test files. The cat file command intended to concatenate files in the standard output device reads a file and displays its contents on the terminal. If the file is too big to fit on a screen, use a pager such as less or more to display it page by page. The editor command runs a text editor such as V or Nano and allows creating, modifying, and reading text files. The simplest files can sometimes be created directly from the command interpreter thanks to redirection. Echo text arrow file, where arrow is a greater than symbol, creates a file named file with text as its contents. Adding a line at the end of this file is possible too with a file such as echo quote more text and quote arrow file. Note that the arrow, not the double greater than symbols in this example. Searching for files and within files. The find directory criteria command looks for files in the hierarchy under directory according to several criteria. The most commonly used criterion is -name that allows looking for a file by its name. The grep expression files commands searches grep, and then you do the expressions, and then you put the files. Command searches This command searches the contents of the files and extracts the lines matching the regular expressions. See sidebar back to basics regular expressions. Adding the R options enables a recursive search on all files contained in the directory passed as a parameter. This allows looking for a file when only a part of the contents are known. B1.4 Managing processes. The PS AUX command lists the processes currently running and helps identifying them by showing their PID, process ID. Since the PID of a process, once the PID of a process is known, the kill signal PID command allows sending it a signal if the process belongs to the current user. Several signals exist. The kill signals terminate it. The most commonly are term, request to terminate gracefully, and kill, forced kill. The command interpreter can also run programs in the background if the command is followed by an ampersand. By using the ampersand, the user resumes control of the shell immediately, even though the user command is still running, hidden from the user as a background process. The jobs command lists the processes running in the background. Running fg percent sign job number fg for foreground restores a job to the foreground. When a command is running in the foreground, either because it was started normally or brought back, the control Z key combination pauses the process and resumes control of the command line. The process can then be restarted in the background with bg job number. This is going to... You can't remember all this from one reading. This is not intended for this book is not intended for someone who's first time using Linux. This is intended for someone who knows how to use Linux but just wanna know about Debian. B1.5 System Information Memory Disk Space Identity. The free command displays information on memory. DF Disk Free reports on the available disk space on each of the disks mounted in the file system. Its H option for human readable converts the sizes into a more legible unit. Okay, free memory or disk free on the disk space. Free command supports M and G options to display data either in megabytes or GB bytes. I don't know what that is. Okay, and the ID commands displays the identity of the user running the session along with the list of groups they belong to. Since access to some files or devices may be limited to a group member, checking availability of group membership may be useful. Hmm, okay, now back to chapter 4. The install of a Bullseye is based on Debian installer. Its modular design enables it to work in various scenarios and allows it to evolve and adapt to changes. Despite the limitations implied by the need to support a large number of architectures, this installer is very accessible to beginners since it assists users at each stage of the process. Automatic hardware detection, guided partitioning, and graphical user interfaces have solved most of the problems that novices used to face in the early years of Debian. Installation requires 256 megabytes of RAM, random access memory, and at least 2 gigabytes of hard drive space. All Falcon computers meet this criteria. Note, however, that these figures apply to the installation of a very limited system without a graphical desktop. A minimum of 2 gigabytes of RAM and 10 gigabytes of hard drive space are really recommended for a basic Office desktop workstation. Upgrading from Buster. If you already have Debian Bullseye installed on your computer, this chapter is not for you. Unlike the other distributions, Debian allows updating a system from one version to the next without having to reinstall the system. Reinstalling, in addition to being unnecessary, could even be dangerous, since it could remove already installed programs. It could remove. It would remove. Upgrade process will describe in section 6.7. Upgrading from even older Debian system directly is not supported. In this case, you need to update gradually from the stable release which followed your Debian version and so on. Previous version of this book will assist you in that matter. Installation method. A Debian system can be installed from several types of media as long as the BIOS UEFI, see note UEFI, a modern replacement to the BIOS of the machine allows it. You can, for instance, boot with a CD-ROM, a USB key, or even through a network. I'll take a look at that UEFI thing. Where are we? Oh, we're in the appendix. Inner workings of a computer, the different layers involved. Hardware, starter BIOS or UEFI, the kernel, and the user space. I read it. B3, Appendix B3, Inner workings of a computer, the different layers involved. A computer is often considered as something rather abstract, and the externally visible interface is much simpler than its internal complexity. Such complexity comes in part from the number of pieces involved. However, these pieces can be viewed in layers, where a layer only interacts with those immediately above or below. An end user can get by without knowing these details as long as everything works. When confronted with a problem such as the internet doesn't work, the first thing to do is identify in which layer the problem originates. Is it the network card, hardware, working? Is it recognized by the computer? Does the Linux kernel see it? Are the network parameters properly configured? All these questions isolate an appropriate layer and focus on a potential source of the problem. Let us start with the basic B31, the deepest layer, the hardware. Let us start with a basic reminder that a computer is first and foremost a set of hardware elements. There is generally a main board, known as the motherboard, with one or more processors, some RAM, device controllers, and extension slots for option boards for other device controllers. Most noteworthy among these controllers are IDE, which is parallel ATA, SCSI, and serial ATA, SATA. for connecting to storage devices such as hard disk. Other controllers include USB, which is able to host a great variety of devices, ranging from webcams to thermometers, from keyboards to home automation systems, and IEEE 1394, which is FireWire. These controllers often allow connecting several devices, so the complete subsystem handling by a controller is therefore usually known as a bus. Option boards include graphic cards into which monitor screens will be plugged, sound cards, network interface cards, and so on. Some main boards are pre-built with these features and don't need option boards. In practice, checking that the hardware works. Checking that a piece of hardware works can be tricky. On the other hand, proving that it doesn't work is sometimes quite simple. A hard drive is made of spinning platters and moving magnetic heads. When a hard disk is powered up, the platter motor makes a characteristic whir. It also dissipates energy as heat. Consequently, a hard disk drive that stays cold and silent when powered up is broken. Network cards often include LEDs displaying the state of the link. If a cable is plugged in and leads to a working hub or switch, at least one LED will be on. If no LED lights up, either the card itself, the network device, or the cable between them is faulty. The next step is therefore testing each component individually. Some option boards, especially 3D video cards, include cooling devices such as heatsinks and/or fans. If the fan does not spin even though the card is powered up, a plausible explanation is the card overheated. This also applies to the main processors located on the main board. The starter, the BIOS or UEFI. Hardware on its own is unable to perform useful tasks without a corresponding piece of software driving it. Controlling and interacting with the hardware is the purpose of the operating system and applications. These in turn require functional hardware to run. The symbiosis between hardware and software does not happen on its own. When the computer is first powered up, some initial setup is required. This role is assumed by the BIOS or UEFI, a piece of software embedded into the main board that runs automatically upon power up. Its main task is searching for software it can hand over control to. Usually, as you may have learned in section 9.1 System Boot, in the BIOS case, this involves looking for the first hard disk with a boot sector, also known as the master boot record or MBR, loading that boot sector and running it. From then on, the BIOS is usually not involved until the next boot. In the case of UEFI, the process involves scanning disks to find a deprecated EFI partition containing further EFI applications to execute. Tool setup, the BIOS UEFI configuration tool. The BIOS UEFI also contains a piece of software called Setup, designed to allow configuring aspects of the computer. In particular, it allows choosing which boot device is preferred. For instance, you can select the USB key or CD-ROM drive instead of the default hard disk, setting the system clock, and so on. Starting setup usually involves pressing a key very soon after the computer is powered on. This key is often Del or S, sometimes F2, F5, F8, or F10. Most of the time, the choice is flashed. The choice is flashed on the screen while booting. If not, you best check the manual if your main board or your main or computer, or you can just bash the F keys, the top row of your keyboard. Something will happen. The boot sector or the EFI partition in turn contains another piece of software called the bootloader, whose purpose is to find and run an operating system. Since this bootloader is not embedded in the main board but loaded from disk, it can be smarter than the BIOS, which explains why the BIOS does not load the operating system by itself. Smarter than the BIOS. For instance, the bootloader, often grub on Linux systems, can list available operating systems and ask users to use one. Usually a timeout and default choice is provided. Sometimes the user can also choose to add parameters to pass to the kernel and so on. Eventually a kernel is found, loaded into memory, and executed. Note: UEFI, a modern replacement to the BIOS. BIOS, which stands for Basic Input Output System, is a software that is included in the motherboard. The electronic board connects all peripherals and executed when the computer is booted, in order to load an operating system by an adapted bootloader. It stays in the background to provide an interface between the hardware and the software. In our case, the Linux kernel. In 2005-2006, its successor, the UEFI, United Extensible Firmware Interface specification, has been published. This specification defines an interface that has the same purpose as the BIOS, but tries to provide more usability, extensibility, and flexibility, a graphical user interface, and true 64-bit support. And it got rid of some of the limitations for BIOS booting. With the usage of a dedicated partition, the bootloaders no longer need special tricks to fit in a tiny master boot record and then discover the kernel to boot. Even better, with a suitably built Linux kernel, UEFI can directly boot the kernel without any intermediary bootloader. UEFI is also the basic foundation used to deliver Secure Boot, a technology ensuring that you only run only software validated by your operating system vendor. Operating system vendor. That would be the Debian Foundation or what it called. Nowadays, most new computers will run UEFI mode by default, but usually they also support BIOS, booting alongside for backwards compatibility with operating systems that are not ready to exploit UEFI. This is called Compatibility Support Mode Module (CSM). But several manufacturers have either announced to cease support for legacy BIOS mode in their UEFI implementations or they already did. This transition, however, has not been without discussion nor without criticism. The BIOS UEFI is also in charge of detecting and initializing a number of devices. Obviously, this includes the IDE SATA devices, usually hard disks, and CD-ROM devices, but also PSI devices. Detected devices are often listed on screen during the boot process. If this list goes by too fast, use the pause key to freeze this for enough to read. Oh, pause key. I thought about that. Pause key works to pause the thing before the OS is right. Install PCI devices that don't appear are a bad omen. At worst, the device is faulty. At best, it's very incompatible with the current version of the BIOS or main board. PCI specifications evolve, and old main boards are not guaranteed to handle newer PCI devices. Both the BIOS/UEFI and the bootloader only run for a few seconds each. Now we are getting to the first piece of software that runs for a longer time, the operating system kernel. This kernel assumes the role of a conductor in an orchestra and ensures the coordination between hardware and software. This role involves several tasks, including driving hardware, managing processes, users and permissions, the file system, and so on. The kernel provides a common base to all other programs on the system. B34, the user space. Although everything that happens outside of the kernel can be lumped together under user space, we can still separate it into software layers. However, their interactions are more complex than before, and the classifications may not be as simple. An application commonly uses libraries, which in turn involve the kernel, but the communications can also involve other programs or even many libraries calling each other. Okay. Then we have install from a CD-ROM, install from a boot key, network booting, and other installation methods. Installing from a disk, CD-ROM or DVD-ROM. What's most widely used installation method is from a CD-ROM or DVD-ROM, which behaves exactly the same way. The computer is booted from this media and the installation program takes over. Various CD-ROM families have different purposes. NetInst, network installation, contains the installer and the base Debian system. All other programs are then downloaded. Its image, that is the ISO 9660 file system, that contains the exact contents of the disk, only takes out about 150 to 280 megabytes, depending on the architecture. On the other hand, the complete set offers all packages and allows for installation on a computer that has no internet access. It requires 19 DV-ROMs or four Blu-ray discs, and there is no more official CD-ROMs set as they were really huge, rarely used, and now most of the computers use DVD-ROMs as well as CD-ROMs. But the programs are divided among the disks according to their popularity and importance. The first disk will be sufficient for most installations as it contains the most used software. There is a last type of image known as a mini.iso, which is only available as a byproduct of the installer. The image only contains the minimum required to configure the network, and everything else is downloaded, including parts of the installer itself, which is why those images tend to break when a new version of the installer is released. Those images can be found on the normal Debian mirrors under the dist/release/main/installer dash arch slash current slash images slash netboot directory. Tip: multi-architecture disk. Most installation CD and DVD-ROMs work only with a specific hardware architecture. If you wish to download the complete images, you must take care to choose those which work on the hardware of the computer on which you wish to install them. Some CD DVD-ROM images can work on several architectures. We thus have a CD-ROM image combining images of the i3, A6, and AMD 64 architectures. To acquire CD-ROM images, you may of course download them or burn them to disk. You may also purchase them and thus provide the project with a little financial support. Check the website to see the list of DVD-ROM vendors and download sites. 4.1.2 Booting from a USB key. Since most computers are able to boot from USB devices, you can also install Debian from a USB key. This is nothing more than a small flash memory disk. The installation manual explains how to create a USB key that contains the Debian installer. The procedure is very simple because ISO images for i386 and AMD 64 are hybrid images that can boot from a CD-ROM as well as from a USB. You must first identify the device name of the USB. The simplest means to do this is to check the messages issued by the kernel using the dmesg command. Then you must copy the previously downloaded ISO image, for example Debian 11 AMD64.iso, with the command cat Debian, the name of file, and then arrow dev/dev/sdb semicolon space sync. This command requires administrator rights since it accesses the USB key directly and blindly erases its content. A more detailed explanation is available in the installation manual. Along with other things, it describes an alternative method of preparing a USB key that is more complex, but it allows you to customize the installer's default options, those set in the kernel command line. 4.1.3 Installing through network booting. Many BIOSes allows booting directly from the network by installing a kernel and a minimal file system image. This method, which has several names such as PXE or TFTP boot, can be a lifesaver if the computer does not have CD-ROM reader or the BIOS can't boot from such media. This installation method works in two steps. First, while booting to computer, the BIOS or the network card boot issues a DHCP request to automatically acquire an IP address. When booted, boot P or DHCP server returns a response. It includes the file name as well as network settings. After having configured the network, the client computer then issues a TFTP (Trivial File Transfer Protocol) request for a file whose name was previously indicated. Once this file is acquired, it's executed as though it were a bootloader. Then This then launches the Debian installation program, which is executed as though it was running from the hard drive, a CD-ROM, or a USB key. All the details, have a look at the section. 4.1.4 Other installation methods. When we have to deploy customized installation to a large number of computers, we generally choose an automated rather than a manual installation method. Depending on the situation and the complexity of the installations to be made, we can use the FAI, fully automatic installer, described in section 12.3.1, or even customize installation DVD with preceding, see section, uh, preceding, preceding, see section 12.3.2, preceding Debian installer. It should also be noted that the installer can load and run an SSH server and thus provides the ability to install Debian remotely via SSH session. The release notes also describe how to run the installer from an existing system using grub to replace it completely. Huh. So you don't need to use the BIOS, maybe. Huh? Using grub. End of chapter 4, part 1.